Alright, what's going on, guys? In this video we'll be talking about how to create a subclass of the threading class. When we subclass the threading class, we actually gain some flexibility. We're able to make some tweaks to some of the objects, thread objects attributes. We can add more attributes, get rid of some attributes, and we could also make some tweaks as to how threads execute their task or the function. So we could make some tweaks to that as well. Now, I'm not going to go into the details of object-oriented programming, but I do plan to create many different instances of threads with sort of different tweaks and different customizations. So you guys should get a feel of what you can do and what you can't do, and hopefully you'll be able to experiment more with subclassing a thread class. Okay, so let's just dive right into this video. The first thing we're going to talk about is, according to the docs, it's only advisable to make changes to a couple of methods. And those two methods are the init method, let me just write this down, init method, and the run method. So these are the two methods that you can make changes to. Well, it's advisable. So I guess you sort of break the code if you make changes to the other methods. So when we subclass, we're going to make changes to these two methods. Okay, so the first thing I want to talk about is the run method, because that's a little simpler. So the run method is actually related to the start method. So if you guys, let me just scroll down. So here's an instance of a thread, and if you guys remember, t.start is what starts the thread. So the run method is related to this t.start method. So what happens is, when we call the start method actually calls the run method. So we don't really see the run method. It's sort of in the background. It's being called by the start method. So the start method will actually call the run method, and the run method is responsible for running the function that we choose. So let me just show you once again. Here we go. So here, target equals sleeper. So this sleeper is the function we're choosing, and the run method is responsible for running that function or executing that function. Now, what we're going to do is we're going to take a look at a portion of the source code. So this is the source code from the thread class, which is in the threading module. So this is the source Python source code, and we're going to take a look at the run method, so we get a better understanding of how we can make some tweaks to the run method. So this is the run method, and the run method representing the thread's activity. See, the standard run method invokes the callable object passed to the object's constructor as the target argument. So the target argument, and the callable object is just a fancy word for the function that we're going to call. And yeah, so don't worry about this too much. So this is the portion of the source code that actually runs the function. So self.target, remember self.target, the target is this, so it represents the function that we want to call. So here is self.target, and it's going to, and these are the attributes, or the attributes, the arguments. These are the arguments that the function will utilize. All these asterisks are doing are unpacking these args. So when we use args, the argument args, we usually put everything in a tuple or a list, because we could have multiple arguments. All this asterisk is doing is that when it calls a function, remember, a function can't call a tuple. So all it's doing is it's unpacking this tuple. So it's taking each element one by one so that it can use each element as an argument. So args is representing this tuple, but we can't put a tuple inside a function as an argument. So what it does is it takes the tuple and it just unpacks each item and uses each item as an argument. All right, so that's all it's doing. Okay, so now that we sort of have the basics, we don't need to worry about this, delete self. I just wanted you guys to know that the run method actually runs the function. So let's make some tweaks now to the run function, the run method. The first thing we're going to do is we're going to create our own class. So let's just get started with that. All right, we don't need this, and here we go. So we're going to first import time, import threading, and now we're going to create our subclass. So we're going to call it myThread, and to our parent class is going to be threading.thread. So these are all just object-oriented programming basics, but this is our parent class, which we're inheriting from. And now we usually start off with an init method, but we're going to not touch the init method. We're actually going to leave it just the way it is with the parent class. So we're not going to make any changes. We're just going to completely inherit init method the way it is. But we are going to make changes to the run method. So the first thing I want to do is we're going to copy and paste this because we don't want to break anything. This is actually self.target is actually something that's from the init method. So we don't want to break any of that. So what we're going to do is we'll just copy this. We don't really need to copy it, and we could actually have a function within this, but this just allows some flexibility to call different functions. We can take a function as an argument and run those functions, as opposed to defining our function within this run method. So now what I want to do is make some tweaks to this run method. So what I want to do is actually add a couple of print statements. So if we go back to our earlier thread code, this is what we used in the threading video 1. What we had to do was we had a lot of print statements. So actually not this one, it was a threading video 2. So what we would do is we would make a print statement. Where is it? Here. Print thread something something has started, thread something something has started. So each time a thread started, we would have to have a print statement. So what I want to do is, instead of us manually having to type that, I'm going to include it. So every time a thread runs, we'll have that print statement. So let's just go back here. So what I'm going to do is, so since this actually runs the function, I'll have a print statement before us running the function, saying something like print has started. Okay. Oh, I use an exclamation point. Oops, I forgot to put there we go. Dot format. And I actually forgot to go over this this method with you guys, but self get name. See this? Self dot get name actually gets the name of the thread. So when we initialize a thread, as you can see here, we put this name. We can actually use this method get name to get the name of the thread. All right, so has started. Okay, so this looks good. Has started, format, blah, blah, blah. And now it's going to run the function, and the next thing we want to do is print it has finished. So let me just, there we go. Has finished. Okay. And I'll just copy this. This is just some lazy programming, but oh well. All right, so has finished, and let me just get rid of that. And I think that looks good. This is our run method. So all we did was add a couple of print statements, and the print statements, first it'll print that the function has, the thread has started, and then the thread will run its function, execute the function, and then it'll say the thread has finished. So instead of us manually having to do this, it's going to automatically run the print statements. Okay, so what we can do is we need a function. So let us just copy this function from video 1. So we'll copy this function from video 1. Okay, here we go. Is that too many? Let's see. This might be too many. Okay, yeah. Too many brackets. Okay. So we have our function sleeper, our function sleeper. What we're going to do is we'll initialize some threads. So for I in range, we'll keep it short. For T. Now here, instead of using threading.thread, since we created our own threading class, myThread, we're going to use myThread. MyThread, and now we just fill in the arguments. Remember, since we didn't change the init, we only changed made changes to the run method. The init is inherited from the threading.thread. So it's the same as the threading.thread because we didn't make any tweaks to it. So we still have all the attributes like target, name, and arg. So target equals sleeper, name equals thread format, this dot format, squeeze this to the next line. Okay, and here instead of using I, because I represents 0, I'll use I plus 1. So that'll just make it a little easier to understand. and we'll just put a comma here. Then we have args equals, what was it? Let's just name it 3 seconds, and it's the name. So let's just copy this. Copy, boom. All right, good. So this looks good. So this is stuff we've went over many times. I'm just initializing the thread, and this looks good. And all we need to do is start. T.start. Start. Yeah, this looks good. So all we're doing is making a tweak to the run method, which is called when we call t.start, and it's going to print out these extra print statements. All right. All right. So this looks good. Let me just. I guess we'll try to run it. All right. So of course, there's always syntax errors, and I forgot to comment those out, and everything else looks good, I think. All right. Syntax error has finished. Here we go. I didn't even see this. Okay. Okay, so I think I fixed all the syntax errors. Now we're going to run it. Okay, it's running perfectly. Let me just pull this out. So let's just go back and review the code. So here, thread 1 has started. That's just the that's the extra tweak we added in the run method. And hi, I am thread 1 going to sleep is part of the function that we're executing. And then thread 2 has started is again the tweak. So we added these tweaks, and we actually don't need to print any of these statements out. They automatically run when we run the function. So that's just a little tweak that we can make to the run function. We can do a lot more. In this case, we just decided to make a small print statement that comes before each function runs. Yeah, so that's just a simple case of making tweaks to the run method. All right, so the next thing I want to do is I want to, let's see, so that was test 1. Now test 2, I want to look over overriding the init method. All right, so let me uncomment this, control 1. All right, so test 2, overriding the init method. So the init method, as you can tell, this is also from the source code. This is from the source code that I pulled out. And these are some of the attributes. So group is something that I think in the future they're going to implement, so we don't need to worry about this. But the common ones we use are target, which is the function, the name, the args and quargs, and daemon thread. So daemon thread, I actually made a video on this, so you guys can check that out if you want. And the asterisk. I'm not really sure what this asterisk is. It's a standalone asterisk. I'm not really sure what that is, but the common ones are target, name, args, quargs, and daemon. So this is the init method. All right, so we can make tweaks to the init method as well, and I'm going to show you that now. So what we're going to do is, let me just copy this portion. Let me just copy this portion. And yeah, so let me just copy this portion, and let me actually indent all this out because I always forget to indent, and that's going to create problems. Let's just indent this as well. Okay, so everything seems to be indented. Okay, so we're good. So we're at test 2. Let me just clean this. Okay, test 2. All right, so, oops, yeah, we don't need that. Okay, so let me just indent this as well. This was just to show you the init method, and now what we're going to do is make some changes to the init method. So what we're going to do is define init. We're going to use self again. Now, let's just use the parameters we want to. So remember, we're actually overriding the init method. So we can add whatever parameters we want to. And we're overriding, so all these parameters are gone. So we don't have any of these. So we sort of have to start from scratch. And I'll show you guys exactly how we can do that. So I want to use 4 different parameters. Self, number, func, and arg. So this is going to represent our function. This is our arguments, and the other parameter is the number. So now, anytime you want to call the init method and you are inheriting from a parent class, so in this case, since we're defining our own init method, you have to actually call the old init method. Dot init self. So do not forget this line. You have to actually call the old init method if you want to define your own init method. So I'm not sure if it's just this case or in object-oriented programming in general, but just remember, you always have to call the init, the original init method. Okay, so now that that's taken care of, what we can do is self.number equals self. So this is just self.func equals func, and self.args equals args. So this is just common object-oriented programming. We're just creating our attributes. Okay, now the run function. So now that we can't use the original run function because the original run function used target, and since we're creating a new init method, we don't have that target attribute anymore. So we have to sort of use the attributes that we created. So that's self. Okay. Now the changes I want to make is what I'm going to do is we have this number, right? So instead of calling threads by names, I'm going to call them by number. So this is going to be thread has started, and what we're going to do is format, and we're going to use self.number. We're going to differentiate each thread by number instead of some sort of name. This is just a very contrived example, but I wanted to just give you an example of how we can make changes to the init method. Okay, so self.func. So remember, before we're using the source code was using self.target. Don't really mind this underscore. It just it means private. So it's just telling you not to call this. So any private methods are methods not to be called explicitly. Anyway, so we're doing the same thing, but instead of target, we're using func because func is going to be holding our function. So self.func, what we want to do is, and then we want to call the args. So self.args, but remember, we have to put, since our args are going to be a tuple or a list, we want to put an asterisk. Okay, so we put the asterisk, and we'll just copy this and do the same thing. This has finished. Instead of started, I'm going to put finished. Okay. All right, so now we need a oh wait, I have an invalid syntax. This is the invalid syntax. All right, so now we need a function. Actually, I decided to change up the function a little bit. So here is cycles. Okay, so all we're going to do is we're just going to double the number for depending how many cycles we have for the amount of cycles we choose. So cycles for I in range cycles, what we're going to do is number plus equals number, and then we'll print out the final number, print number. I guess I want to change it around. We're always using the time.sleep, so I felt like maybe it would be a little more interesting. Yeah, so we have this define double. Now let's just in this case, I'll call a bunch of threads. So what we want to do is we'll create a threads list equals, and then what we want to do is for I in range, let's just do something like 50. T equals my thread. Remember, we're using my thread because this is the new class we created, and now we have number. Okay, so number is actually going to be representing the number of the thread. So we want to have number equals, and we want to make it I plus 1 because I starts off with 0, and I wanted to name the threads 1, 2, 3, 4, 5, and so on. So until 50. And now func. Before we were using target. Let's go back to our arguments. We have number, func, and arg. So we're going to use number, and next is func. So func is going to equal our function. In this case, it's going to be double. And the args, we could create a list or a tuple. I'll create a list this time because I've always created tuples. And we're going to have our args represented by I. So we're going to use the I as the number we want to start off with. And the amount of cycles, we'll just use something like 15. All right, so let me just push this over to the next line. All right, so it's pretty much the same way we initialized the other threads, but in this case, we're using our custom arguments. Now for T in threads list, T.join. So threads list, of course, this time I don't want to forget a couple of things I don't want to forget is threads list.append t and t.start. So all right, so we've gone through this many times. Same code as the last previous videos. The only change is the way we're initializing everything. So number equals 1 plus I plus 1, and the number is going to be used here. Self.number. So thread 1, thread 2, thread 3, thread 4, all the way to 50. The function that we're going to use is double, and the args is I and 15. So I is going to be represented by number, and for the amount of cycles is 15. So we're going to be doubling our number for 15 times. And threads list, we've done this before. We're going to append everything, start everything, and then t.join to make sure everything does finish. So let me just actually wait. Invalid syntax. Let's see. So I forgot to add in. All right. This looks good. Let me just run this, and we'll just make some space here, and I'll run it. Syntax error. My thread init self. Let's see. Sorry about this. It's supposed to be self. This is supposed to be self. Okay. Sorry. Self.number equals number. Just a couple of simple, silly mistakes. That's why we're getting this strange output. I was like wondering why we're getting this output. I made a mistake here. Instead of putting number, put self. So okay, so everything should be good now. So let me just run this. Okay, so that was pretty quick. We ran 50 instances, and of course some of it is out of order, but here we go. So thread 1 has started, 0, thread 1 has finished, thread 2 has started, and this is the, I guess maybe this is, if you double it 15 times. I'm not sure if these are correct numbers. 4, yeah, I'm not really sure why the numbers are coming out so large. Let's see, let me just change this to 3. Okay, for I in range, the cycles, yeah, so if you change it to 3 cycles, the number should be coming out a lot lower. So let's see, let me just run this again. So 0, so thread, let's see, 0, then 1. Yeah, the numbers are supposed to, they're incrementing, the number keeps getting bigger, and then you're adding that bigger number. So it seems like it's supposed to be incrementing this much. But let's just go back to the beginning of this, and let's just see how it runs. So thread 1 has started, 0, thread 1 has finished, thread 2 has started, 8, thread 3 has started, 16. We're able to sort of reconstruct the threading class, not from the beginning, but we were able to create our own init and our own run method, and we're able to utilize the threading class in a way that we wanted to. So we made a couple of tweaks, and even though these tweaks are not really beneficial, it just gives you an idea of what we can do with init. Maybe I'll make another video showing some more concrete examples that we can use. But I just wanted to give an example of how we can tweak the init method as well as the run methods to create a thread class that we want, to create a thread class in a way we want. All right, so I have actually one more example, but I think this video has gone on a little longer than expected, so I'm going to actually put it in the next video. That's it for this video. I will see you guys in the next video. The next video will be a continuation of this video.